Okay, we are going to look at what we're going to call two-step problems today, and that means that you're going to use two conversion factors. So we're going to call this a two-step problem, and that means it's going to have two conversion factors. So what does that mean? It means when you're working the problem, you're going to start with a number, and you're going to have a conversion factor here and a conversion factor there. So you're going to end up with two conversion factors. So how do you know that you're going to need two conversion factors? How can I look at a problem and get that information? How can I figure out that I have a two-step problem? Okay, so this is very straightforward. What you're looking at is you're going to read the problem, and when you read the problem, you're going to look at the unit. So this says, how many molecules, unit 1, are there in 24 grams, unit 2, of the iron 3 fluoride? Okay, so nowhere in that problem did they use the word moles. So they didn't talk about moles. Nowhere in the problem does it say anything about moles. It's not represented in the problem. So if it doesn't say moles, it's going to be a two-step problem. So how do we set up our two-step problem? You're always going to do this the same way. You're going to start with the number, and in this case, the number is 24. So you're going to write that here, and that's grams of FeF3. Okay, next step, conversion factor number 1. Here's conversion factor number 1. It's a times, multiplication symbol, and a line. And so I have a top and a bottom to my conversion factor, a numerator and a denominator. And so it's really simple to do conversions. If you have a unit and you're trying to convert it, that means you don't want the unit, or you wouldn't be doing a conversion. So we have grams. We don't want grams. We want to get rid of them. So whatever unit is in this position, in the first thing you write down, whatever unit you have there, that unit is going to be the one we're going to get rid of. So we have grams. We don't want grams, and so that is going to go to the bottom of the conversion factor. That could say anything. It could say atoms, moles, molecules. It could say anything, and that unit goes to the bottom. Now, that doesn't tell us the number. It tells us the unit. Now, the other side of the conversion factor is going to be 1 mole. All right, so we've got to figure out what this FeF3 is. And so what you're going to do is you're going to go to the periodic table and you're going to find iron and fluorine, and you're going to add those up, and those are going to be what we call molar mass. Okay, so molar mass is what we're going to be looking for next, and that's how much a chemical weighs on the periodic table. So I'm going to slide over here, go to my periodic table, and I've got iron right here, 55.85. And then if we go back, you're going to see we also have fluorine, 3 of those. And so we'll come over here, and that's going to be right there at 19. So I'm just getting that information from my periodic table. So we're going to come over here, and we're going to add up all those values. Okay, to save time, I went through and I wrote out molar mass and what it equals. And so here's the iron, the 55.85. There's only one of those. And then here's the fluorine, 19. And I multiplied that by 3 because there's 3 of them, and I got 112.85. So that's going to go up here into this spot right in front of grams at 112.85. Every time that you are going to do a conversion with grams, that number is going to come from the periodic table. Okay, now, if you stop right now, you would have an answer in moles. That is not what the problem is asking for. It's asking for you to get all the way to molecules. And so we have to go and do a second conversion factor to get to molecules. Now, moles and molecules are definitely not the same thing. Molecules are not going to use grams. They're going to use Avogadro's number. But for you, that's going to be 6.02 times 10 to the 23rd. So this is the number, 6.02 times 10 to the 23rd. That's the number that you're going to use if you have molecules, ions, atoms, basically anything that's not grams or liters. Then you're going to use this number right here. It doesn't say grams, doesn't say liters, you're going to use that. So you can really put whatever unit you want with it. So we're going to use molecules. Now, let's come up here and we're going to add another conversion factor, and our space is going to get a little small, so I'm going to put that here. And then that's going to be moles we want to get rid of. So remember I said the units on top we need to get rid of, so we don't want moles. We need to get rid of it. That goes to the bottom. So let's slide down here and let's put 1 mole on the bottom. Right now, you're going to always have 1 in front of the mole, so it doesn't really matter. It's always going to have a 1 in front of it. But up top, and I'm going to run out of space here, so I'm going to put 6.02 times 10 to the 23rd, and that would be a molecule. And I'm going to just abbreviate that, MOLEC. All right, so now, if you look, we have everything we need. Now I'm going to go ahead and erase the molar mass here so we have a little space. So I'll erase this. And what happens now is you're going to do the math, and then you're going to do all of this in your calculator at once. And so when you do that, then that's going to come down here, and that's going to give us our final answer right there. Okay, so how do we enter all this into our calculator? Okay, so the way it's going to work in your calculator is you're going to put 24 in. You're going to divide by 112.85 because that's on the bottom. So we divide when things are on the bottom. And then we're going to multiply by 6.02 times 10 to the 23rd because that is on the top. Okay, so I jumped ahead and I wrote the math out to kind of show you what we're looking for. And so you're going to put your starting number, 24, in your calculator, hit divided by, put 112.85 in, and then hit enter. So I usually hit enter after every operation. And then since the 6.02 times 10 to the 23rd is on top, then we're going to go ahead and we're going to multiply times 6.02 times 10 to the 23rd. Okay, now here's the issue, getting that number into your calculator. So you can do it a couple of ways. You can plug it in 6.02. You can look for a button that is either a double E or an EXP. Both of those mean exponential. So double E or EXP. And then plug in 23. So what these buttons mean, they mean times 10. So you don't need to hit times, you don't need to hit 10. So that's option 1. Option 2. Option 2 is to use carets, and that's often common in math classes. So you can go 6.02 times 10 caret 23. But here's the issue with carets. You need to put the whole expression in parentheses, or the calculator will often get this incorrect. And so if you're going to use carets, you need to put the expression in parentheses. If you're getting numbers like times 10 to the 48, things like that as an exponent, you know that that's a significant problem that you got to deal with. Okay, so let's go to the calculator and let's plug this in. So we've got 24, and then again, 112.85 is on bottom. So we're going to hit divided by 112.85. And then we can go ahead and hit enter. And then we're multiplying by 6.02 times 10 to the 23rd. So we're going to hit multiply. And then I'm going to go 6.02. There's the exponential. And then I'm going to hit 23. So no times, no 10. 6.02 E23. Hit equals. And then that says 1.28 and a bunch of values times 10 to the 23rd. E plus 3 means, so E plus 3 is going to mean, that means times 10 to the 23rd. That's what that's trying to tell you. So your answer, and sometimes your calculators will have this times 10 to the 23rd or whatever the final value is. They're going to have that in the display. And so we need to go ahead and write down that final answer. And so we only have, 24 only has two values in it. Two significant figures is what we call it, but it has two values. So let's just round the answer to two values there. 1.28, I'm going to change that to 1.3 times 10 to the 23rd. No point in writing out your entire display. So 1.3 times 10 to the 23rd, and those are molecules, and those were molecules of FeF3. So that gets you a good setup. Now I want to show you another setup here where you're going to be going from molecules. So let's slide down there. Okay, let's look at number 10. How many grams are in 3.3 times 10 to the 23rd molecules? Again, we did not say the word moles. Moles is not in this problem, and so we know it's a two-step problem. If it said moles, it would be easy. One step. We're not that fortunate, so we're going to have to do a two-step problem. So let's start by writing down the number. 3.3 times 10 to the 23rd. And I'm going to put the unit on the bottom because I'm going to run out of space if I don't. And that's going to be molecules of the N2I6. So then we're going to go ahead and add our first conversion factor. And so the unit again is kind of in the way, so I think I'm going to erase it. And we'll go ahead and drop in our first conversion factor. Okay, we have molecules, we need to get rid of them, so they're going to go to the bottom. And so that's going to be 6.02 times 10 to the 23rd. And those are going to be molecules. You could abbreviate it MOLEC, and that would be perfectly fine. But notice, still going to have the mole on top. I got rid of the molecules. That's a good thing. And so if you look, my molecules, this is supposed to be on top, and that's on bottom, and so they cancel. So that's a good thing. Then we're going to go ahead and go to the unit that they want. They want grams. And so that means now, opposed to the different than the one we did a minute ago, my second conversion factor is going to have grams on top, and it's going to have 1 mole on the bottom. So grams, again, where do we get grams? Well, we're going to go to the periodic table and we're going to look up molar mass of N2I6. Okay, to speed things up, I kind of jumped ahead and added then the molar mass. So here is what nitrogen weighs, and there's 2 of them. And then 126.90 is what iodine weighs, and there's 6 of them. I do the math, and I get 789.42. So that's going to go right here. And then we're going to do the math. Now, the math is going to be very similar to the last one, except 3.3 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times 789.42. So that's going to be the process. So let's take a look at that. Okay, so this is what you want to put in your calculator. 3.3 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. So if we go to our calculator, that 3.3 exponent 23 is what you're after, divided by 6.02, and then we'll hit equals, and then we're going to multiply by 789.42. 789.42, and you're going to get 432.7. And so we're going to go ahead and round that a bit. So there's my final answer. I went to 2 sig figs, 432 actual values, but just round the best you can. And then again, my units canceled, moles on top and bottom. And so this is kind of the things that'll get you through. Divide when things are on the bottom, multiply when they're on top, and you should be in good shape.